Greetings, my beloved scholars. It's great having you once again. Jam past question 2001, question number 38. In the diagram below, determine the RMX current. RMX current, simply meaning root mean square current. We also have root mean square voltage. Let's start with that. What is root mean square current? Recall we have two types of current, AC and DC. AC stands for alternating current. DC stands for direct current. The type of current that we get from our generators, alternators, is AC. It moves to and fro. The current has reversed motion. It moves like a wave, and it also brings about electric shock when you make contact with a live wire. Now we have DC. DC moves in one direction. It's unilateral. It's one directional. Okay, in DC, there's nothing like electric shock because it moves in one direction. The type of energy we derive from batteries or cells or even the sun is DC, direct current. Okay, when we talk about root mean square, we're talking about heating effects. Heating effects. If a certain value of AC gives me heating effect of 100 joules and another certain value of DC gives me the same heating effect, we now call that DC the root mean square value of that AC. Let me give you a clear example on the board. Take for instance, we have 2 amps AC giving me 100 joules of heat. AC, I have 100 joules of heat. Then I'm looking for equivalence in DC that will give me the same 100 joules. That equivalent value is what we call the root mean square value. Then common sense will guide you to understand that if 2 amps of AC is costing 100 joules, it will take more in DC to cost the same 100 joules. That is the root mean square value. The DC equivalent of AC that will give me the same heat rating as the AC. Okay, observe on the board. So it may be taking around, I'm just giving an instance, it may be taking around 2,000 amps of DC to create the same 100 joules as 2 amps of AC. Yeah, we'll have more heating here compared to there. So to match the heating, we'll have more value at the DC category. That's what I mean by the root mean square value. Then going back to our question, to do justice to that, okay, we are looking for root mean square current, therefore we're bouncing back to Ohm's law. Observe the diagram. We have voltage, we have resistance, and we have reactance. Reactance, this symbol stands for inductive reactance. When an inductor is in your circuit, the inductor will also pose some challenge to the flow of current. It will also offer its own resistance. The resistance of an inductor is called inductive reactance. It's also resistance. So we have 2 resistances here. One is from a resistor, the other one is from an inductor. Then bouncing back to Ohm's law, recall, Ohm's law says that current is equal to voltage over resistance. That's Ohm's law. I is equal to V over R. Since we're talking about root mean square value, see what we do. Then add root mean square to your current. Also add root mean square to your voltage. Birds of a feather flock together. So root mean squares will go together. But there's nothing like root mean square resistance. The resistance is always the same. We'll carry on. Then I'm looking for root mean square current. Observe in our circuit diagram, we already have the root mean square voltage. Then to solve, root mean square current is equal to root mean square voltage, that's 240 volts, all over resistance. Here I have 2 resistances. Observe, I have resistance of a resistor and reactance or resistance of an inductor. To solve that, I will deploy a new method called impedance. Impedance. This is where you have multiple resistance in the circuit. Then the impedance says root mean square current is equal to 240 over, instead of R, because R favors only resistance of a resistor. So to favor both, I will introduce impedance. Impedance is known as the total opposition offered to the flow of current in a circuit. So to involve inductor in the opposition, I'll be using impedance. And to solve impedance, To solve impedance, recall. Impedance says square root of R squared plus XL minus XC all squared. Where Z stands for total opposition or impedance, R stands for resistance to the resistor, X subscript L stands for reactance or resistance of an inductor, minus X subscript C, reactance or resistance of a capacitor, all squared. Then observe a circuit diagram. There is no capacitor. We have only inductor and resistor, no capacitor. Then the impedance becomes R squared plus, this becomes 0. 0 minus this is that same thing. We're having X subscript L all squared. So that's our impedance. Then let's solve and get the impedance. The impedance is square root of R, we have 4. 4 squared plus inductive reactance, we have 3. 3 squared equals 4 squared will give me what? 16 plus 3 squared will give me what? 9. Okay? Equals, add up, we'll be having square root of 25. Square root of 25. So I'll finish up here. Then I'll go back here. Recall we're looking for root mean square current. Therefore, root mean square current becomes 240 all over the impedance. The impedance is root 25. Then root mean square current is equal to 240 all over square root of 25 is 5. Finally, root mean square current becomes 48 amps. The quotient, 48 amps. Okay, please stay tuned as we push ahead. Do subscribe.